Alright, so last problem we dealt with derivatives. This problem we are dealing with integration because we are finding the area of the region bounded by the conic and the x-axis given that ugly, ugly, ugly equation. And what do we need to do? Well, we need to find the area, which means we need to evaluate a definite integral. So I'm going to expand the right side of this equation, that x plus 1 squared, and I'm going to do that to get x squared plus 2x plus 1, and then I'm going to multiply by 6 on both sides to get rid of that fraction out front. So I'm going to get a 6 in front of there, and that will equal a y plus 216, so I'm also going to subtract 216 from both sides. Essentially, I'm solving this equation for y, because that is how I know how to integrate, and that is how you should know how to integrate as well. So let's see what we can do. Well, we can distribute that 6, so y equals 6x squared plus 6 times 2 is 12x plus 6 minus 216. But let's go ahead and change that as well. 6 minus 216 is negative 210. The difference between 216 and 6 is 210. If you added 6 to 210, you get 216, but it is a negative 216, so there you have that. A little bit of mental math for you. We have this ugly, ugly equation, and we need to integrate this equation. So let's integrate this function. Let's not do that. Let's integrate this function 6x squared plus 12x minus 210. Let's integrate that with respect to x. And what do? Well, the power rule for integration says we add 1 to the power. So we add 1 to x and get x cubed, and then we divide by that new power. So 6 divided by 3 is going to give us a 2x cubed. Plus our 12x will become an x squared, add 1 to the power, then divide by that new power when you are integrating. So 12 divided by 2 is going to give us a 6x squared minus 210 gets an x. And this would be our antiderivative right there. It would have a plus c, but we need to evaluate an indefinite integral, which means we will be looking between specific x values and subtracting the lower value from the higher value, which means we would be adding c and subtracting c, which means it's not going to affect a indefinite integral. So I just said indefinite. I'm going to say definite. My bad. But we need to do some things with this equation first before we can actually use this antiderivative that we just found. Well, we need to figure out what this parabola looks like. What do we know? Things we know is that the x term is squared, which means it's up and down. What else do we know? Well, we know the vertex is down at negative 216 with an x value of negative 1. So the vertex is down there. The coefficient there is positive, which means it's opening up, which means we're dealing with some situation like this. And we're finding the area between those two x-intercepts, which, make note, is negative, so our answer should be negative. But we need to find that area right there, which means we need to figure out what that x value is and what that x value is, so we can plug that in and subtract. This looks like a creepy drawing, like, hi, what's up? Okay, so let's go about doing that, figuring out what those x values are. Well, how are we going to figure out what those x values are? Well, let's take this equation, this 6x squared plus 12x minus 210, and let's factor it to find the x-intercepts. So y equals, I'm going to factor that 6 out, I'll be left with x squared plus 2x minus whatever 210 divided by 6 is. Well, it just so turns out that 210 divided by 6 is 35, which means we will have minus 35 right there. Let's keep going. Y equals 6 times x plus or minus something times x plus or minus something else. What are those somethings? Well, what are two numbers that add to multiply to negative 35 and add to positive 2? Well, I think it has to be a negative 7, and I'm a liar, a positive 7, and a minus 5, because 7 times negative 5 is negative 35, and 7 plus negative 5 is positive 2. And so I have it factored, which tells me that those x-intercepts, those points right there, will have x values of negative 7 and positive 5. So really what I'm looking at here is I'm looking at this integral right there, that indefinite integral, I'm looking at as a definite integral from negative 7 to positive 5. So you have to remember what that means. That means take your higher number, the positive 5, plug it into this function. So 2 times 5 cubed plus 6 times 5 squared minus 210 times 5. Take that whole expression, subtract from it the lower number plugged in, negative 7. So we're going to subtract from that whole thing, let's just do it right here, we're going to subtract a 2 times negative 7 quantity cubed plus 6 times a negative 7 quantity squared minus 210 times a negative 7. And we're going to subtract that entire thing from the bigger number plugged in. So let's go through and let's simplify some things. Well, let's see. What is 5 cubed? 5 cubed is 125. 125 times 2 is 250. Plus 5 squared is 25 times 6. If you have 6 quarters, how much money do you have? We have $1.50. So we have 150 right there. 6 times 25 minus 210 times 5. Well, I know that 5 times 10 is 50. I know that 5 times 2 is 10. So let's say 1050 right there. So we're going to take that whole expression, whatever it works out to be, and subtract this lower one. And you know what? I'm tired of doing mental math, so I'm actually just going to plug into my calculator at this point and simplify this down to a single number. Remember that this whole expression here needs to be determined first before you subtract it, unless you want to distribute that negative to all pieces. Remember that that negative 7 is being squared, which means that better be a positive number when you're done, and the negative 7 is being cubed, which better be a negative number there. So simplify all of this out, and you should find that you get negative 1,728. Again, we know that area has to be negative because we're dealing with an area that is below the x-axis. So there you have it. What did we do? Well, we took the antiderivative, we integrated the function after expanding it and solving it for y, and then we factored our equation to determine the x-intercepts, and then we plugged in the bigger number and subtracted, plugging in the smaller number to get our total of negative 1,728.